Hello, everyone. Welcome to the show. You know the name of the show right up there. So today we're going to be talking all about Saturn. Because in a couple of weeks now, we're going to be debuting a new show in the planetarium called In Saturn's Rings. I've been waiting for this show for quite a long time. Since I became producer, I was hearing about this show In Saturn's Rings, how it does not use CGI. But what they did was they took millions of pictures of Saturn and footage of Saturn, and they meticulously stitched these together to create a seamless narrative, a film composed of only of photos and real footage of Saturn. It is the closest you will come to visiting Saturn probably in your whole life. I'm going to go ahead and guess here. I've already seen the show, so I can attest that it is probably the best show we've debuted in our planetarium. It's in 4K. It looks beautiful. It is quite astonishing. Quite a Herculean feat to accomplish such a film. So next week, I'm going to do an interview with the director of it. We're going to talk a little bit about the film, what it took to make the film, what he's working on, some inside details about In Saturn's Rings. And then the week after that, we will debut the film. So keep an eye out on our Facebook page and on our website to see when that show will be playing in the Planetarium Theater. So this week, the week before the interview, I want to show you where you can find Saturn in our nighttime sky, and I want to show you hopefully some details about Saturn that you don't really quite know about. The hexagon at the North Pole, some images detailing the rings, some of the new moons that were found. So let's just get right into it. I'm going to take myself out of this. There we go. And let's begin. So to start things off, let's learn about where we can find Saturn in our sky tonight. Okay, drink some of my coffee here. Now, it is quite easy to find Saturn, actually. Super easy, barely an inconvenience. All you have to do is wait for sunset. Right about 7:30, you will start to see two bright objects almost directly overhead. Now, you might think that these are stars, but actually they're going to be Jupiter and Saturn. Now, obviously, Jupiter is going to be the brighter of the two. Not only is it closer to us, but it is larger. But to the east of Jupiter, or to the left of wherever you're looking at it, you will see another bright object, and that is going to be Saturn. Well, Jupiter will appear in the area of the sky called Sagittarius, and even though Saturn is technically in Sagittarius, it will appear to be in between Sagittarius and Capricornus. So that is how you can find Saturn tonight, not only a little before sunset, but well after sunset as well. Now you can also see Mars over here, peeking over the horizon, over there on the east. And last week we covered some detailed images of Mars, courtesy of HiRise, and that is still up on YouTube, and I believe it's probably still up on the LASM Facebook page. So you can still check that out. If you go on YouTube, you can look up LASMBR, and you'll see not only these videos, these We Need Our Space videos, but many other videos as well. But let's get into Saturn, because I want to cover this as much as possible before next week's show, where I interview the director of our upcoming new planetarium film, In Saturn's Rings. All right, so let's go visit Saturn up close as much as we can here. Now we have to travel the 885,904,700 miles or so just to get there, but when we do, we'll be able to see that familiar gas giant with its brilliant ring system. Okay, so here is an opportunity to talk about a misconception of Saturn. Many people think that Saturn is the only planet in our solar system with rings. They like it because it has rings and it's the only planet that has rings. But actually, all the gas giants in our solar system have rings. Jupiter's got rings, Uranus has rings, even Neptune has rings. However, the rings of those planets very faint and not as vibrant as Saturn's. We can see the rings of Saturn so much better than the other gas giants because Saturn's rings are composed of chunks of ice, rock, icy rock, and debris. So a lot of ice in those rings of Saturn that reflects the light of the sun, and therefore we can see those rings so much better than the other rings of the gas giants. In fact, whenever Galileo first observed Saturn through his telescope, he thought the rings were two other objects at Saturn's side. He described them as ears. They kind of look like ears if you tilted it kind of front-facing. We've got these little ear-looking things on Saturn. So there's another misconception about Saturn that has been floating around over the years. And I remember hearing this whenever I first started working at the planetarium. It's that Saturn has a density that is less than water. So if you could find a body of water large enough, Saturn would float on the water. But that isn't quite true. In a sense it is, but then again, we have to look at this realistically. Now, I don't want to give you the impression that Saturn would float on water like a balloon or like a piece of styrofoam. So let's kind of take a look at this for a second and see exactly what's going on with this Saturn floating on water business. Now, first of all, if you could find a body of water that was so large that you could immerse Saturn into it, Saturn wouldn't exactly float on the surface like a inner tube, but it would sort of float more like an iceberg floats. Now, there'd be a small bit above the water and then a large amount below the water. This body of water would have to be so deep that it would be as deep as 6 Earths stacked on top of each other. So if you had a massive object that was able to have an ocean as deep as 6 Earths, and then you would have an object that would be so massive that the liquid metal core at the center of Saturn would be pulled down into this massive object, and the remaining gas that makes up Saturn would then disperse across the planet's immense water area. But yeah, Saturn might be able to float in a way, but it's not really the way that you would think that it would float, and it's more of a hypothetical situation of thinking about the density of Saturn. So not that an object could be that big, but it's just my opinion. Let's talk about those rings of Saturn for a second. Of course, if you talk about Saturn, you've got to talk about the rings of Saturn, right? Well, Saturn has an extensive ring system. It is surrounded by thousands of rings that are made up of tiny pieces of rock and ice and dust and debris. And it's that ice that makes Saturn's rings so reflective and noticeable. So astronomers have identified 3 major rings. You've got ring A, B, and C. And a set of fainter rings, ring D, F, G, and E. Now, these rings are extremely wide and may extend up to 248,548 miles from the planet's surface. Now, you've probably noticed this gap in the rings. This wide gap between the rings A and B is about 3,000 miles wide. It's the largest gap of all the gaps you'll notice. The gap is called the Cassini division, and it is named after its French discoverer Jean de Cassini. Now, he first discovered this in 1676. What should be noted is that Saturn spins fastest out of all the planets that spin on their axis. It completes one rotation in about 10 hours and 39 minutes. 10 hours, 39 minutes, but it does take a long time to make one trip around the sun. About 10,759 of our Earth days. About 10,759 of our Earth days is a year on Saturn. Now, we've had a few spacecraft shoot past Saturn over the years. There's been Pioneer 11, Voyager 1 and 2, but the Cassini-Huygens probe was the one that really was able to send back some amazing images of Saturn. Not only that, but the Cassini orbiter was able to discover 4 new moons. It found Methone, Pallene, Polydeuces, and Daphnis, which you'll notice appears in an area called the Keeler Gap. Let's go visit Methone right now. Let's take a look at what Methone looks like here. And then you've got Pallini. We'll visit Pallini, see how these look. And then you've got Polydeuces. Crazy looking moon here. You'll see that they look a little different than moons often appear. And then you've got Daphnis here. Now Daphnis really looks kind of odd, so let's kind of talk about why that is. So you probably noticed that some of the moons we just saw look a little bit like ravioli. There's this skirt around the center of these rings. Well, why is that? The gravitational influence of Saturn is key to these odd-shaped moons. These moons were probably formed due to collisions by tiny or tinier moonlets. Well, Saturn's mass is 95 times Earth's mass, and these moons with these skirts orbit Saturn much closer than our moon orbits us. Now, therefore, these moons experience a great amount of tidal force that is constantly trying to pull them apart. What is called a pyramidal region scenario, these moons were formed by many collisions by other tiny moonlets, and they were shaped by the gravitational forces of Saturn. So there you have it. You have these strange moons influenced by the gravity and the tidal forces, and then collisions by moonlets that form these odd-looking little skirts or ridges along the equatorial plane of these moons. Well, Saturn is composed primarily of hydrogen and helium, just like Jupiter is composed primarily of hydrogen and helium. And there's other stuff in there as well, stuff like methane, water, and ice. These are all present, but that's what you're seeing when you see these colored bands of Saturn. There's storms of gas raging across the planet around 1,000 miles per hour. So if you thought a hurricane was bad, you would not like to visit Saturn. However, Saturn doesn't have the fastest winds in the solar system. A distinction would go to Neptune, which has winds a bit faster than Saturn. The fastest winds in the solar system goes to Neptune. But back to Saturn here. Well, there's also this interesting looking hexagon on the northern pole of Saturn. Now, this was first viewed by the Voyager flyby. Yes, the Voyager flyby in 1981. And now, with that came a bunch of weird conspiracy theories. Call them conspiracy theories, but it's these weird theories that aren't necessarily connected to reality. Well, these range from it being an alien spacecraft to a time cube. Yeah. They think there's some type of time cube in there. I don't know. Well, you name it, people will dream it up. But this hexagon can actually be explained by fluid dynamics. Now, you've got these winds circling the pole going one speed, and then you have winds further down going at another speed. Now, it has to do with the gradient between the two storms that we're seeing here. There's the area between these two very different storm layers, and this produces a very messy area in between. So the fast spinning winds closer to the northern pole are going at one speed. Then there is another set of winds further down that are going at a much slower speed. And then there's this area between that is very messy, and it produces a sound wave. Now, if you have ever seen a sound wave or a string being vibrated, you'll see that it's not one huge long wave. There are these peaks and valleys. So when you have two sound waves that interact with each other, they can cancel each other out at certain points. And that is what is happening here. The sound wave is going around the poles and going around the diameter of the northern region of Saturn, and at certain points these waves are canceling out. Now, this was tested in a lab, and they were able to tune these drums of water rotating at different speeds, and then they injected dye to, lo and behold, create this smaller version of the hexagon on Saturn. Now, they tuned this in various other ways to form ovals and other shapes. So yes, they were able to duplicate the pattern that you see on Saturn, as well as create other shapes. So that shape doesn't have to be explained by conspiracy theories or sort of crackpot explanations such as a strange time cube, but it can be described and explained via good old-fashioned fluid dynamics and how wave frequencies interact with each other. And with that, I'm going to conclude this show. So now you can go outside and you can view Saturn as it appears almost directly overhead to the left, depending upon where you're at, but mainly to the left of Jupiter. Next week, we will have an interview. I'm not going to try to pronounce his last name because I'll probably butcher it. But Stephen, from the director of In Saturn's Rings, and then the following week, you can look forward to In Saturn's Rings. Well, not the following week, but the week after next week's interview with the director of In Saturn's Rings will debut In Saturn's Rings at the planetarium. And you can come by and you can watch it in our theater in person. Won't that be fun? And with that, folks, enjoy the rest of your evening and the rest of your week. I will see you next week. Bye.